everyone, so today we are going to solve a very interesting problem number 143, and the problem is about reordering the list. And the problem says you are given a head of a single linked list. This list can be represented as L0, L1, L of n minus 1, Ln. Reorder the list to be of the following form. Okay, there is some form that we have been given, and it has asked us to not modify the value of the list node. Only nodes themselves can be. So we have to change the order. And there is example that we have 1, 2, 3, 4, and it wants us the order like this 1, 4, 2, 3. And if it is 1, 2, 3, 4, 5, then we have 1 attached to 5, which is set L 0, 0 will get to n, 1 will get to n minus 1, 2 will be. So we have a pattern in. So to solve this problem, what I will do is I will observe this pattern that they have asked us to do. So what I will do is we have the linked list like this 1, 2, 3, 4, and we want to connect 1 to 4, then 4 to 2, and 2 to 3, right? And the order is 0 will be getting connected to n, 1 will get connected to n minus 1, and 2 will get connected to n minus 2. So it's a fairly simple approach looking to me. So what I will do is first I need to break this list into two halves so that I can do the required order. So I will break the list in the middle, and to break I need to first get the mid of my linked list, so which I will do using one slow and fast pointer. And then once we have the list in this form 1, 2, and 3, and 4, so here will be our mid, and this will be our head. Then what we'll do is we'll reverse this portion of this linked list, other half that we have, so it will become 4 and then 3, and then we'll merge these two parts as per the problem definition. So we have the reverse, and then we'll merge these two together in the required format. So our steps is get mid, reverse the list, and then merge the list. So we'll write the code using the software engineering best practices like we have described. So what we are doing is basically first thing that we are doing is we are breaking the problem into steps, and then we are writing modular code for each step, and then we are combining the results. So this is what my approach would be to solve this problem. And now let's get into the coding part of it and see how we can write this. So one thing we need to check is could our head be none, so it is not given. It is given that node value will always be between 1 and 1000, and node will lie in the range, so there will be a minimum of one node, but just for best practices we'll keep the edge case that if our head is none or a head next is not none, then we'll just return. So we'll say if not head and head dot next is also not none. So head dot next, then we'll immediately return. So like discussed, first we need to get the mid. So we'll write one get mid function to get the mid. Then we'll reverse this mid. So for that we'll write one function to reverse the linked list, which is a pretty standard way of writing the reverse. And then what we'll do is we will merge this head with the reverse part of the reverse list of the second half that we have created originally. So now first thing what we need to do is we need to write this mid function of how to get to the mid. So what I'll do is we need two pointers. So we are passing the head node into our mid function, and we'll initialize two pointers slow and fast. And so fast would be one step ahead of two steps ahead of slow, because we need to get to the middle when the fast has reached to the end. So we'll keep one more pref pointer to break the list. So while fast is not none and fast dot next is not none, we'll continue. So we'll make the fast pointer two steps and slow pointer would be one step. Slow pointer will go one step. Slow dot next, and we also need to break the list in between. So we'll give the pref the value for the slow, and in the end when both slow and fast have reached, when fast has reached to the end, then slow would be reached to the middle, and there will break our list. So we need to do pref dot next is equal to none, and in the end we'll return the slow pointer. So this will give us the slow pointer. So we can also see how our mid is looking just for verification in the end. And now let's write the code for reversing the linked list, that reverse mid. So again we are passing one, let's say it's head, and this is the list node again, and it's a pretty simple straightforward tool how we reverse a list. We need one pref, we'll assign one current to head, and until the current is not none, we need one next temp node to hold the current dot next node, and then we'll reverse the linking by current dot making current dot next is equal to pref, and then pref will become current and current will become the next dot temp. So that's the standard way of doing reversing a linked list, and in the end we want this pref to be written. So now we have two parts where we have the required code in the order, and now we need to write the code so we can also see how this reverse of linked list basically, or mid, when it will get reversed, how it will look like. It should look like 4 3, because initially the mid is 3 4. So we can also verify that in the end, and we need to now merge our two halves, the first half which has only head and the reverse part as per the definition. So we'll write one merge list function. So let me name that merge list, So this is merge list, and we are merging these two, head and reverse. So what we'll do is we'll see until the let me name it like list1, and this is list2. So this is one list node, and this is another list node. And until my second half list node has not become null, what we need to do is we need to swap the we need to establish the connection of list1 next to the list2 next. So what we're doing is we are assigning one list node, we are assigning the list1 next into a temporary next node variable, and then we are assigning this next to the start of the list2, and then we are doing list1 to list2, and in the end we'll assign this list to the next node that we have. So this would give us the order that we are looking for, and now let's run our solution and see how it performs. Merge list. Okay, this is merge list. We are merge list. Okay, so this is our mid as promised. Mid is 3 4, and then we are reversing this mid, and then we are merging these two parts as per the problem definition where I've been given, like we have to merge the first to the last. So we are merging the first part of this list into the second part of the reverse list. So now let's submit our solution and see how it performs for all the test cases. Oh, we don't want these now, and we don't want these now. Oh, so we are failing for just one test case of ours. So if the input is just one, then we are not having a okay. So what we'll do is, oh, so what we need to do is, if our head is not, if our head is not none, or our head dot next is not none, then we need to return. So now let's run it for all the example test cases and submit our solution. Okay, so this has been accepted for all the test cases, and this would be the theory for solving this problem. So thank you.